The Blackstone Valley in the autumn of 1858 was a place where water met iron, where rivers bent to the will of industry. The valley stretched for miles, carved deep by glaciers 10,000 years before, and now it held something new, the steady rhythm of manufacturing. Mills dotted the riverbanks like sentries, their brick facades darkening with coal smoke, their windows catching the low afternoon sun. The Arkwright Mill stood on the eastern bank of the Blackstone River, 4 stories of red brick and timber framing. It was not the largest mill in the valley, but it was reliable. For 23 years, it had turned raw cotton into finished cloth, employing 217 souls from the surrounding townships. The building smelled of machine oil and cotton lint, a thick scent that settled into clothing and hair and became part of the people who worked there. Inside, the main floor stretched nearly 200 feet. Rows of power looms stood in tight formation, their cast iron frames bolted to the wooden floor planks. Each loom was connected by a system of leather belts and pulleys to a central line shaft that ran the length of the building, suspended from the ceiling by iron brackets. The shaft turned constantly during working hours, driven by the great water wheel outside, and from it all motion flowed. Every loom, every winding machine, every card taking its power from that single rotating spine. The workers moved between the machines with practiced efficiency. Women and girls tended the looms, their fingers quick and certain, watching for broken threads and empty shuttles. Men worked the heavier machinery, the carding engines that combed the raw cotton, the heavy presses, the maintenance of the power transmission system. Children, some as young as 9, crawled beneath the looms to gather fallen cotton and clear the debris that accumulated in the narrow spaces where adults could not reach. The sound was constant, but not chaotic. Each machine contributed its own voice to the collective rhythm, the clack of shuttle boxes, the whir of spindles, the deeper groan of the line shaft turning in its bearings. Those who worked there learned to hear patterns in the noise, to detect the slight change in pitch that meant a belt was slipping or a bearing needed grease. The mill had its own language, and the workers became fluent. The morning shift began at 5:30, when the stars still hung over the valley. Workers arrived in the darkness, their breath visible in the cold air, carrying tin lunch pails and small lanterns. The mill whistle announced the day, a long steam-powered note that carried for miles, waking households and setting the rhythm for the entire town of Millbrook. By 6 o'clock, the water wheel was turning, the line shaft was spinning, and 200 voices were swallowed by the sound of industry. Thomas Wickham was the mill's chief engineer, a man of 46 years who had come up through the ranks. He had started as a bobbin boy at 14, learned the machinery by observation and necessity, and now held responsibility for keeping every mechanical system in operation. He walked the floors 3 times each day, his hand trailing along the line shaft supports, feeling for vibration, listening for irregularity. He knew which bearings ran hot, which belts stretched more than others, which sections of the shaft had been replaced, and which dated back to the mill's construction. On the morning of October 14th, 1858, Wickham arrived before the whistle. He often did. He liked the mill when it was still and quiet, when he could hear the river outside and the settling sounds of the building itself. He checked the water wheel mechanism, greased 3 bearings on the second floor line shaft, and made notes in his leather-bound maintenance log. Everything was in order. The morning was cool but dry, good working weather. The first shift filed in at their usual time. Sarah Pritchard took her place at loom 17, as she had for 8 years. Robert Henley climbed to the 3rd floor to operate the carding machines. Mary and Catherine Dunn, sisters aged 12 and 14, reported to the winding room on the 2nd floor. The routines were ancient, measured not in years, but in thousands of repeated mornings. By 7 o'clock, the mill was at full capacity. The line shaft spun at 70 rotations per minute, transferring power to 48 looms, 6 carding engines, and assorted auxiliary equipment. Outside, the water wheel turned steadily, pulling energy from the river's endless downstream flow. The Blackstone had been dropping 120 feet over 20 miles for centuries. Now that fall turned iron and moved cloth. The day proceeded as 10,000 days before it had proceeded. Until it didn't. The first indication came from the third floor at 11 minutes past 9. A bearing housing on the line shaft, a cast iron collar that held one of the support journals, had been developing a hairline crack for 6 months. The crack was internal, invisible, running through a thin section of the casting where a bubble of air had been trapped during the original pour. The bearing had been installed in 1847, 11 years earlier, and had turned millions of times without complaint. But metal remembers stress. Each rotation, each tiny flexion, propagated the crack deeper into the structure. At 9:11, the bearing housing fractured. The sound was sharp but brief, a crack like a tree branch snapping, almost lost in the general noise of the mill. The line shaft, suddenly unsupported at that point, dropped 3 inches. The sudden shift threw the shaft out of alignment. The heavy iron rod, still spinning at 70 rotations per minute, began to whip. Wickham was on the first floor when he felt it, a new vibration coming up through the floor planks, a shuddering that had not been there a moment before. He looked up at the ceiling and started moving toward the stairs. On the third floor, the freed section of shaft swung in its adjacent bearings, torquing them beyond their design limits. Leather drive belts, suddenly pulled at wrong angles, began snapping free from their pulleys. The first belt to fail was driving a carding engine. It whipped through the air like a striking snake and wrapped around a vertical support post. The second belt snapped 6 seconds later, and the third 4 seconds after that. Workers nearest the failing section reacted on instinct, most backed away from their stations. One man, Robert Henley, ran forward, not toward the shaft, but toward the wooden gearbox that controlled power distribution on that floor. There was a lever there, a manual clutch that could disengage the floor's machinery from the main shaft. It was rarely used. Henley reached it and threw his weight against the lever. The clutch mechanism, stiff from disuse, resisted for a moment and then gave way. The third floor equipment shuddered to a halt. But the line shaft continued to spin. On the second floor, the whipping motion had traveled down the shaft's length. The entire rod was now oscillating, unsupported at one crucial point, flexing in ways the material was never meant to flex. Another bearing, stressed beyond tolerance, began to fail. This one did not crack. It simply tore free from its mounting bracket, pulling bolts through aged wood. The shaft dropped again, this time on the second floor, and the geometry became catastrophic. With 2 support points gone, a 30-foot section of iron shaft weighing nearly half a ton was being held only at its ends. The spinning weight created harmonic vibration. The shaft began to bow. Workers on the second floor heard a deep groaning sound, metal under impossible strain, and then the shaft broke. It did not shatter. It fractured at a weak point near one of the remaining supports, and the long section of iron, still spinning, still carrying momentum, fell into the space between the floors. It crashed through wooden flooring, severed 3 belt drives, and came to rest at an angle, one end lodged against the first floor ceiling joists, the other embedded in the second floor boards. The sound of the impact silenced the mill. For a moment, there was only the echo of breaking wood and the continued rumble of the water wheel outside, still turning, still trying to drive a system that no longer existed. Then came the smaller sounds, the hiss of a broken steam line that had fed a heating pipe, the clatter of tools dropped in surprise, the voices of workers calling to one another across the floors. The entire sequence, from the first crack to the shaft's final position, had taken 43 seconds. Wickham reached the second floor and stopped in the doorway, taking in the scene. A shaft of daylight cut through the dust where the fallen line shaft had broken through the outer wall. The air was thick with cotton fibers, shaken loose by the impact, drifting in the disturbed air like snow. The machinery stood silent, looms frozen mid-stroke, drive belts hanging loose or torn. And there, bisecting the workspace like a fallen tree, lay the main line shaft. He did a quick count. All the workers were standing. No one had been beneath the shaft when it fell. By chance or providence, the heavy iron had found empty space. There were minor injuries. One woman had been struck by a flying piece of wood and had a cut on her forearm. Another worker had twisted an ankle rushing down the stairs, but nothing grave. Wickham felt the tension drain from his shoulders, replaced immediately by another concern. The mill had stopped. For the first time in 23 years, in the middle of a working day, the Arkwright mill was silent. The mill's superintendent, Jacob Mercer, arrived within 10 minutes. He stood beside Wickham, looking at the broken shaft, calculating. The mill had contracts. There were deadlines. 3,000 yards of cotton cloth were scheduled for delivery to Boston by the end of the month, another 5,000 to New York by mid-November. The Arkwright mill ran on thin margins, as all mills did. Time was not a luxury. Mercer asked the obvious question: how long for repairs? Wickham walked the length of the damage, examining the shaft, the broken supports, the damaged floor structure. A section of shaft would need to be fabricated. That meant a foundry, a casting, machining to proper diameter, balancing. The floor would need to be rebuilt, reinforced. New bearing housings, new brackets, new bolts through solid lumber. He did the mathematics in his head, added time for delays and complications, and gave Mercer his answer. 5 weeks minimum, possibly 8. The superintendent's face did not change, but something shifted behind his eyes. 8 weeks of lost production would cost the mill $15,000 in unfulfilled contracts, possibly more in reputation, and lost future business. The mill employed 217 people. Those people fed families. Those families bought goods from local merchants. The town of Millbrook existed because the Arkwright mill existed. 8 weeks was not just time. It was a cascade of consequences rippling outward. By noon, word had spread through the town. The mill whistle had not blown at the shift change, and that silence was louder than any alarm. Workers gathered in small groups outside the mill gates, uncertain. Some still wore the cotton lint in their hair. They spoke quietly, sharing what they had seen, speculating about what would come next. The mill posted a notice by 2 o'clock. The building would be closed for repairs, duration unknown. Workers would be notified when operations resumed. There was no mention of wages during the closure. There rarely was. Sarah Pritchard read the notice and walked home in the middle of the afternoon, something she had not done on a weekday in 8 years. The town looked different in daylight, unfamiliar. She had a husband and 3 children. They lived on her wages and his work as a carpenter. He had steady work now, but winter was coming. Winter always brought uncertainty. The Dunn sisters walked home together, their hands still stained with machine oil. Their family rented a small house on the east side of Millbrook, along with 2 other families. 11 people in 6 rooms. The girls' wages kept their younger brothers in school. Without those wages, the boys would need to find work. They were 8 and 10 years old. By evening, the economic reality had settled over Millbrook like frost. The mill was not just a workplace. It was the structural element that held the community together. The boarding houses that sheltered workers, the general stores that extended credit against mill wages, the blacksmith who made repairs, the teamsters who hauled cotton in and cloth out, all of it depended on the steady pulse of manufacturing. The mill tried to continue payments to key personnel, engineers, supervisors, skilled machinery operators. But the majority of workers, those who tended looms and hauled cotton and swept floors, received no wages. Some found temporary work at other mills in the valley, though jobs were not plentiful. Others took on day labor, harvesting late crops, cutting firewood, anything that paid. Some families simply waited, hoping the repairs would move quickly. Inside the mill, Wickham assembled a crew of 6 men. They began the slow work of removing the fallen shaft section, cutting it free from where it was wedged, lowering it with chains and block tackles to the ground floor. It took 4 days. Then began the work of surveying the full extent of damage, documenting every broken beam, every cracked support, every compromised section of floor. Wickham sent specifications to 3 foundries in Massachusetts, requesting bids for a replacement shaft section. The specifications were exacting: diameter, length, material composition, straightness tolerance, balance requirements. The shaft would need to integrate seamlessly with the existing sections, turning at the same speed, carrying the same loads, lasting another 20 years. The responses came back over the following week. 2 foundries declined. The work was too specialized, the tolerances too tight. The third, Horton Foundry in Worcester, agreed to take the job but warned of complications. To cast a section of shaft that would meet the required specifications would take 3 weeks minimum, possibly longer if the first casting showed flaws. And that assumed their furnace remained in good order and their iron supply held. Wickham sent the order. While they waited for the casting, his crew rebuilt the support structure. They cut new beams from hardwood timber, installed reinforced brackets, replaced damaged floor sections. The work was methodical, careful. Each element needed to be stronger than the original because no one wanted to face this problem again. The town settled into an uneasy rhythm. Families adjusted. Some children left school, finding work elsewhere. Some families moved away, following rumors of jobs in Connecticut or Rhode Island. The general store began refusing credit to mill families. The boarding houses, half empty, lowered their rents to keep tenants. And in valley towns beyond Millbrook, mill owners took notice. The Arkwright accident was not unique. Line shafts had failed before in other mills, other towns. But the scale of this disruption, the total stoppage of a major mill for an extended period, concentrated attention. Insurance companies began asking questions. Local authorities, seeing the economic impact on Millbrook, began considering regulations. And engineers, men like Wickham who kept the machinery running, began talking among themselves about the vulnerabilities built into the system. The replacement shaft section arrived from Worcester on November 19th, 5 weeks after the accident. It came on a flat wagon pulled by 4 horses, wrapped in canvas and straw for protection. Wickham and his crew uncrated it in the mill yard, measuring and inspecting. The casting was good, straight, properly dimensioned, the surface machined smooth. They hauled it inside using a makeshift crane, lifted it to the 2nd floor, and began the delicate work of installation. Aligning the new section with the existing shaft required precision, measured in fractions of an inch. The coupling had to be perfect, or the entire shaft would run out of true, creating vibration that would tear the system apart again within weeks. Wickham spent 3 days making adjustments, shimming supports, testing alignment with plumb lines and levels. When he was satisfied, they bolted the coupling collars and tested the rotation by hand, turning the entire shaft slowly to feel for binding. On November 23rd, they engaged the water wheel. The shaft began to turn under power for the first time in 40 days. Wickham watched, listened, felt the vibration through the floor. The system ran smooth. They brought the speed up gradually over the course of an hour, reaching full 70 rotations per minute by noon. The mill held together. Workers were notified to return on November 25th. 217 had been employed before the accident. 163 came back. The rest had found other work or moved away. The mill would need to hire and train replacements. But something had shifted. The Arkwright accident had forced conversations that had been deferred for years. The Mill Owners Association of the Blackstone Valley held a meeting in December 1858 to discuss mechanical safety standards. It was the first such meeting in the association's history. 23 mill superintendents and owners attended, along with a dozen chief engineers. Wickham was there. He presented a detailed report on the Arkwright failure, the causes, the progression, the ultimate damage. He did not speak as an advocate or reformer. He simply laid out the facts. The bearing housing had failed due to a hidden defect in the original casting. The resulting shaft misalignment had propagated the failure through the system, and the mill's inability to inspect internal structural components meant such defects were invisible until they became catastrophic. The mill owners listened because the accident had cost them all money. Not directly, Most had no connection to the Arkwright mill, but indirectly, through increased insurance premiums, through tighter credit from banks concerned about industrial risk, through the attention of state authorities who were beginning to ask uncomfortable questions about workplace safety and economic stability. The meeting resulted in 3 formal recommendations, distributed to all member mills. First, that all line shafts more than 15 years old should be systematically inspected and replaced on a scheduled basis rather than run to failure. Second, that bearing housings should be sourced from foundries willing to guarantee material quality and provide proof of inspection. Third, that mills should maintain reserve capital sufficient to cover at least 4 weeks of lost production, protecting both the business and the workforce from complete collapse during repairs. These were not laws, they were suggestions, economically motivated, born from self-interest rather than altruism. But they spread. Mill owners in Rhode Island heard about the Blackstone Valley recommendations and adopted similar policies. Engineers in Connecticut began specifying higher quality components. Insurance companies offered reduced premiums to mills that implemented preventive maintenance programs. The changes were subtle, incremental, barely visible to the workers who returned to their looms and carding engines. But in the aggregate, across dozens of mills and thousands of workers, they mattered. Catastrophic shaft failures became less common. Mills that once ran equipment until it broke began scheduling maintenance. The culture of fix it when it fails began, slowly, to shift toward prevent it from failing. There was another consequence, less immediate but more profound. The Arkwright accident had revealed the fragility of the single-shaft power distribution system. One failure point could stop an entire mill. Engineers began exploring alternatives. Some mills in Massachusetts experimented with multiple independent line shafts, each driving a section of machinery so that a failure in one would not cascade through the whole system. Others began investigating steam power as a supplement to water power, allowing mills to continue operation even when the river ran low or ice jammed the water wheel. By 1862, 3 mills in the Blackstone Valley had installed steam engines alongside their water wheels. The engines were expensive, inefficient by later standards, and consumed quantities of coal, but they provided independence from the river's whims and redundancy against mechanical failure. If one power source failed, the other could keep at least part of the mill running. The technology was not new. Steam engines had existed for decades, but their integration into textile mills accelerated after 1858. The Arkwright accident had not invented the solution, but it had concentrated attention on the problem. It had made visible what had always been true, that industrial systems built on single points of failure were economically vulnerable, and that vulnerability had human consequences measured in lost wages and displaced families. Legislation followed, though slowly. Massachusetts enacted its first factory inspection law in 1867, 9 years after the Arkwright accident, requiring state-appointed inspectors to examine machinery in textile mills and report on conditions. The law was weak, poorly funded, and inconsistently enforced, but it established a precedent that the state had an interest in industrial safety and that mill owners were not the sole judges of acceptable risk. None of this happened because of the Arkwright accident alone. History does not turn on single events, but the accident was a visible moment in a longer transformation, a point where abstract concerns about industrial risk became concrete and immediate. It was the crack in the bearing housing that made the invisible problem visible. The Arkwright mill continued operating for another 47 years. It survived the financial panic of 1873, the labor conflicts of the 1880s, and the gradual decline of the Blackstone Valley textile industry as manufacturing moved south. In 1905, the mill closed permanently, unable to compete with newer facilities in the Carolinas where labor was cheaper and regulations fewer. The building stood empty for 13 years. In 1918, during the height of the First World War, it was briefly reopened to manufacture canvas for military tents. After the war, it closed again. The wooden floors began to rot. The windows, broken by vandals and weather, let in rain. The line shaft, still in place, slowly rusted in the damp air. In 1932, the building was purchased by a machinery salvage company. They removed the line shaft section by section, along with the looms, the carding engines, the waterwheel mechanism. The metal was sold for scrap, melted down, recast into other forms. The building itself was partially demolished, the upper 2 floors taken down, the walls reduced to half height. The red brick, still solid, was repurposed for construction elsewhere in the valley. What remains today is a footprint and a foundation. The site is marked by a small historical plaque installed in 1976 by the Millbrook Historical Society. The plaque mentions the mill's years of operation and its role in the local economy. It does not mention the accident of 1858. Thomas Wickham, the engineer who managed the repairs, worked at the Arkwright Mill until his retirement in 1881. He died in 1893, age 81, having spent his entire adult life in textile manufacturing. His maintenance logs, leather-bound books filled with careful handwriting documenting decades of repairs and inspections, were preserved by his family and eventually donated to the Blackstone Valley Historical Society. They sit now in a climate-controlled archive, available to researchers but rarely consulted. Sarah Pritchard returned to her loom after the repairs and worked at the Arkwright Mill for another 11 years, until failing eyesight forced her retirement. She lived to age 73. Her children grew up, found work, raised their own families. One of her grandsons became an engineer, though not in textiles. He worked on railroad bridges. The Dunn sisters, Mary and Catherine, both left mill work within a few years of the accident. Mary married a shopkeeper and moved to Providence. Catherine became a school teacher, one of the first women in Millbrook to complete normal school training. She taught for 36 years. The families that were displaced during the mill closure, those who moved away, who found work elsewhere, who never returned, dispersed into the larger pattern of industrial America. Their names appear in census records and city directories in distant places, evidence of migrations too small to be called historical events, but large enough to change individual lives completely. The mill owner's recommendations of December 1858, those 3 careful suggestions about maintenance and capital reserves and quality control, were never formally adopted as law. But they spread through practice and precedent, becoming part of the unwritten standards that governed industrial operation. By 1900, most large textile mills in New England operated under principles that would have been familiar to the engineers who gathered in that meeting. Inspect regularly, replace before failure, maintain reserves against disaster. The accident itself faded from memory. It was not dramatic enough to warrant national attention, not deadly enough to inspire reform movements, not tied to any famous names or larger historical narratives. It was simply one of thousands of industrial incidents in the 19th century. A shaft that broke, a mill that stopped, a town that suffered, a system that adapted. But adaptation is how systems evolve, not through grand redesigns, but through incremental adjustments forced by failure. The line shaft that fell in 1858 was replaced by a stronger shaft, which was eventually replaced by multiple shafts, which were eventually replaced by individual electric motors, which transformed the entire nature of industrial power distribution. Each change built on the lessons of previous failures. History moves that way, not in straight lines or clear narratives, but in accumulated adjustments, in responses to problems that reveal themselves only in the breaking. The factory accident that rewired a nation did so not through a single dramatic moment, but through the slow work of engineers writing better specifications, owners calculating risk more carefully, inspectors noting defects before they became catastrophes. The Blackstone River still flows through that valley, dropping the same 120 feet it has dropped for millennia. The water wheels are gone. The mills are gone or converted to other uses, apartments, museums, office space. But the valley remains, shaped by the forces that moved through it, both natural and human. And somewhere in an archive, in leather-bound logs written in careful handwriting, are the daily records of a man who knew that systems fail, that metal fatigues, that nothing built by human hands lasts forever without attention. Those records are evidence of a simple truth, that history is not made only in the grand moments we remember, but in the small decisions, the careful maintenance, the lessons learned from failure and passed quietly forward. The factory accident of October 14th, 1858, lasted 43 seconds. Its consequences lasted decades. And in that gap between event and consequence lies the real story of how a nation learned to build its industrial machinery more carefully, not because it wanted to, but because it had to, one broken shaft at a time.